Hey, this is Mrs. Reichelt, and our next video we're going to talk about is cardiac output. So basically, cardiac output is a formula that we're going to use to determine the amount of blood that's pumped by each side or each ventricle during a 1-minute time period. So in order to calculate the cardiac output, we have to know a couple of the other terms before. So the first term here is called stroke volume. Stroke volume is the amount or the volume of blood that's pumped by each ventricle in one contraction or within each heartbeat. This number typically remains constant. It'll change if you're bleeding or if your pressure's really messed up, but for the most part, it's about 70 milliliters of blood that's pumped out of the left ventricle with each heartbeat. This will obviously change based on whether you are a really tall female or a really tall male or a really short and petite female, but for the most part, we're just going to play it safe and call it 70 milliliters. We also, hopefully you know what this one is, we have our heart rate. Your heart rate is basically 75 beats per minute. That's just the average. Yours is probably a little bit less than that, but in average, most heart rates are about 75 beats per minute. So in order to calculate our stroke volume here, we have our cardiac output, which equals our heart rate times our stroke volume. So basically, we take our heart rate, which is 75 beats per minute, and our stroke volume, which is 70 milliliters per beat, which means that we can then cross out beats because we're multiplying it by itself. So we're going to have how many milliliters per minute. Those are going to stay. So if we do that math, we have 5,250 milliliters of blood that's pumped per minute. Sometimes this is called the Starling's law of the heart. So that means that the more cardiac muscle is stretched, the longer the contraction will be. Changing heart rate is the most common way to change cardiac output. So basically that means that your stroke volume typically remains the same unless you're bleeding out or something, but your heart rate is what can change pretty easily, whether you're doing an aerobic exercise or whether you're just sitting on the couch eating popcorn. So our next little spot here is how our heart is regulated. So if we have an increased heart rate, typically our sympathetic nervous system will be activated. Remember, our sympathetic is our fight or flight system. So that means that it's going to be increasing in a crisis, which indicates, or we have some low blood pressure there. Also, you can increase your hormones or increase your heart rate due to hormones, things like epinephrine. This is your fight or flight response as well as thyroxine. Exercise will increase this, and also a decreased blood volume will increase your heart rate. So your heart will decrease rate based on the parasympathetic nervous system. This was your resting and digesting system. So if you have high blood pressure or blood volume, you're going to try to decrease the heart rate. And if you have a decrease in the venous return. I think that this is a really cool diagram because it really gives you an idea of what types of things are going to increase and or decrease I almost said the nervous system, but it'll increase or decrease whatever your heart rate is. So these are going to act as responders to each other. So if you have a crisis, then your sympathetic nervous system is going to increase your beats per minute. If you have low blood pressure, your sympathetic nervous system will increase, and then it'll increase the contractile force, which will increase your stroke volume, which will increase your cardiac output. So this is kind of a cool table. I don't think you have to memorize it or anything, but it's kind of cool to sort of see how the cardiac output is regulated. All right, so our next up here we have our cardiovascular imbalances. So there's a couple that we're going to talk about here. Congestive heart failure is the first one. Typically, congestive heart failure is a progressive condition, meaning that it's not one day you have it and it's really, really bad. It means that it's going to you're going to have it and it's going to get worse over time. So this is when you have a weakening of the heart by the coronary. Basically, your arteries are becoming clogged. The heart eventually fails, or one side fails. And then the next one is called pulmonary edema. Basically, pulmonary edema is when you have fluid. Edema means that it's swelling. So you have fluid that's building up in your lungs. So if this was your lungs and you have pulmonary edema, you have fluid that's building up into your lungs. And that'll cause your lungs to leak fluid. Usually it's water or blood vessel fluid, that sort of thing. But that's another cardiovascular imbalance that, even though it occurs in the lungs, it's going to affect your cardiac output, which affects your cardiovascular system. All right. Well, that wraps it up. So I'll go ahead and let you go. But I hope you found that helpful.